Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
This is the concept video for derivatives of exponential functions. So an exponential function is a function that takes the form f of x equals some base to the power x. And a special one of these functions is f of x equals e to the x. So we're trying to differentiate these kind of functions. So we'll do a quick derivation of it, but we need to know one fact beforehand. The limit as h approaches 0 equals e to the h minus, the limit as h approaches 0 of e to the h minus 1 over h equals 1. This is a fact. So, to find the derivative of f of x here, we're going to use the definition of the derivative, which is the limit as h approaches 0 of f of x plus h minus f of x over h. So in this case, we have the limit as h approaches 0 of e to the x plus h minus e to the x all over h. And we can use some exponent rules here to turn e to the x plus h into e to the x times e to the h. And then we can factor out e to the x from the limit entirely, because it doesn't depend on h, and the limit only deals with h. So now we're left with e to the h minus 1 over h, which is the limit that we have the rule for up here. So we know that equals 1, so we got e to the x. So the derivative of the exponential function e to the x is e to the x. So we can write this as d dx of e to the x equals e to the x. But this isn't the case for functions with a different base, like 2, 3, 10, or whatever. To find what that is, we'll use the chain rule. So if you want to find the derivative of some a to the x, so first we got to know how to change the base on this. So if you exponentiate this by e, then you need to also take the inverse of it, or the inverse of the exponential function, which is ln. So this is a valid operation, just like you can add 1 and subtract 1 to something and keep it the same. So if we exponentiate it, and we ln it, and then we exponentiate it, we can use log rules to take the exponent out of the ln and make this e to the x ln a, or e to the ln a times x. So this is a good quality to know. So when we're taking the derivative of this, let's make it the derivative of e to the ln a times x. So since we know the derivative of e to the x, we can use a chain rule to find the derivative of this. So this is going to be e to the ln a x times the derivative of ln a x, which is just ln a. Then we can use this equality but backwards. E to the ln a times x equals a to the x, and we get that a to the x times ln a is the derivative. So d dx of a to the x is ln a times a to the x. And notice that a has to be positive because we can't have the ln of a negative number. So this isn't valid for negative bases. And just a quick fact, you can easily figure this out, but it's good to know, I guess. We often see functions in the form e to the power of some function of x, and the derivative using the chain rule is g prime of x times e to the x, or e to the g of x. So yep, that's how you take a derivative of an exponential function.